In those Nmap lectures, we have seen no port scan, also known as ping scan, different ways of scanning ports, SYN scan, also known as half-open scanning, TCP scan, also known as TCP Connect scan, and UDP scan. Now let's see some more details to be able to use Nmap more effectively. We have found the hosts and open ports of them. Now is the time to find out the services which are listening to those ports, and the version of those services. In addition, let's detect the operating systems running on those systems. Suppose that you ran an Nmap query and it told you that ports 25 TCP, 80 TCP, and 53 UDP are open. Using its Nmap services database of about 2,200 well-known services, Nmap would report that those ports probably correspond to a mail server, SMTP, web server, HTTP, and name server, DNS, respectively. This lookup is usually accurate. The vast majority of daemons listening on TCP port 25 are, in fact, mail servers. However, you should not bet your security on this. People can and do run services on strange ports. Even if Nmap is right, and the hypothetical server above is running SMTP, HTTP, and DNS servers, that is not a lot of information. When doing vulnerability assessments, or even simple network inventories of your companies or clients, you really want to know which mail and DNS servers and versions are running. Having an accurate version number helps dramatically in determining which exploits a server is vulnerable to. And version detection helps you obtain this information. After TCP and/or UDP ports are discovered using one of the other scan methods, version detection interrogates those ports to determine more about what is actually running. The Nmap Service Probes database contains probes for querying various services and match expressions to recognize and parse responses. Nmap tries to determine the service protocol, for example, FTP, SSH, Telnet, HTTP. The application name could be ISC bind, Apache HTTPD, Solaris Telnet-D. The version number, host name, device type, something like a printer or a router, and the OS family, you know what that is, Windows, Linux, etc. So let's see how to use service and version detection in Nmap and why it's important. Okay, go to Kali and open a new terminal window. Let's create the Nmap scan command. Nmap is the command itself. N is to avoid the DNS resolution. Uppercase PN is to avoid the host discovery. I'm using the SYN scan this time. I write the destination IP, which is the IP address of my Metasploitable VM, and the destination ports, the top 10 ports. Let's run this command first to see the results of a command without version detection. Now, I open a new terminal window to create a new Nmap command. I prepared the command with the same configuration. SYN scan, Metasploitable, and top 10 ports. I add S uppercase V parameter for version detection and hit Enter. As you see, the query takes longer this time. The SYN scan without the version detection took less than a second, and the SYN scan with version detection took about 12 seconds. In the first query, service names are estimated by Nmap according to the default services running on those ports. In the second query, on the other hand, Nmap probed the ports to determine more about what is actually running. Now, I want to show you the most important reason of using version detection in Nmap queries. In Kali, I'm going to run SSH on port 443 and then scan the port with Nmap. Let's perform the demo together. First, look at the listening services if SSH is running. Netstat, TNLP. SSH is running on port 22 at the moment. Type service SSH stop to stop SSH service and hit Enter. Now, to change the port of SSH, we're going to change the configuration. Open the sshd_config file with a text editor to change it. I use Nano text editor for this purpose. Type nano/etc/ssh/sshd_config and hit enter. Find the port line, delete the sharp to make it a valid configuration line. The sharp was used to make it a comment line. Change the port number to 443. Control X to exit Nano, Y to save changes, and hit enter to save over the existing file. Start SSH again using the service SSH start command. Look at the listening ports to double-check netstat TNLP. SSH service is running on port 443 now. Let's scan port 443 of Kali with Nmap. Prepare the Nmap synscan command. No version detection for this query. Nmap detects that the port is open. Look at the service. Nmap says the service is HTTPS. Using its Nmap services database, Nmap reported that this port probably corresponds to a web server for HTTPS, and we know that's not true. So let's prepare the Nmap synscan again, but this time use S_V parameter to run the version detection mechanism. Now, as you see, port 443 is running and the service is SSH, not HTTPS. Version detection interrogated the port to determine more about what is actually running. Nmap queried the port using the probes of the Nmap service probes database and matched expressions to recognize and parse responses. And the version of SSH is OpenSSH version 7.6p1. So, if you are not 100% sure about the type of the running service on a port, run version detection. Got it? Good. So one of Nmap's best-known features is remote OS detection using TCP/IP stack fingerprinting. Nmap sends a series of TCP and UDP packets to the remote host and examines practically every bit of the responses. After performing dozens of tests, such as TCP/ISN sampling, TCP option support and ordering, IP/ID sampling, and the initial window size check, Nmap compares the results to its Nmap OS/DB database of more than 2,600 known OS fingerprints and prints out the OS details if there's a match. Each fingerprint includes a freeform textual description of the OS and a classification which provides the vendor name, for example, Sun, underlying OS, that would be Solaris, OS generation, let's say 10, and device type, general purpose, router, switch, game console, whatever. OS detection is far more effective if at least one open and one closed TCP port are found. So let's see the OS detection in action. We have to use OS detection with one of the port detection techniques. So I use synscan for this demo. The target system is Metasploitable. Let's choose top 100 ports to make the query faster, or just don't give any port. Let the Nmap scan top 1,000 ports. That won't take long. Put uppercase O for OS detection and hit enter. Here is a result of OS detection. It's a general-purpose device and running Linux with a version between 2.6.9 and 2.6.33. If you would like Nmap to be more aggressive to have a more accurate result, you can use OS_SCAN guess parameter with OS detection parameter. Now, let's scan a Windows system and try to find out the version of the OS. So here I have a Windows 8 virtual machine. I want to learn its IP address first. Open a command prompt, type ipconfig, and hit enter. Now let's go to Kali and test if we can reach the Windows system. First, I'll ping the system. No, the system is not responding to the ping requests, or we cannot reach the system. So second, I perform an Nmap ping scan. We know how to do it, right? Type Nmap SN 172.16.99.171 and hit enter. Yes, Nmap says the host is up. So we are able to reach the system. Now I want to scan the top 10 TCP ports of the system. I add the reason parameter to see the reasons of the results. All the ports we scanned are filtered because there are no responses from them. It's not good for us. So I add the OS detection to the latest Nmap query and rerun it. No, Nmap cannot find the OS details because it does not have a result set to probe or interrogate. I would like to open a port on the Windows system and reply the Nmap scans. In Windows 8 VM, I run the IIS, Internet Information Services Manager, and start to host the default website of IIS. Open a web browser and try to reach the website typing the IP address of the system into the address bar. Okay, web service is up. Let's test if I can reach the website from Kali. I go to Kali, open a browser, enter the IP address of the Windows 8 VM, and hit enter. No, I cannot, and I think I know the reason. In Windows VM, let's look at the firewall if HTTP traffic is allowed. So I open the firewall. At the upper left corner, I click Allow an app or feature through Windows Firewall link. Click Change Settings, which needs to have admin privileges. Go to the end of the list. As I thought, HTTP services are not allowed. Check it and click OK to apply the changes. Now in a command prompt to see port 80, I run netstat an command. When I come back to Kali, I see that the page is loaded in the browser. That means Kali can reach port 80 of my Windows 8 VM. Now in Terminal Screen, I want to run SynScan for the Windows system's top 10 ports. Here we have an open port now. So let's reply the scan with OS detection option. Now we have the OS detection result. First, Nmap warns us about the results. It says the results may be unreliable because it couldn't find a closed port to probe. But anyway, Nmap makes it best. And here it says the operating system is one of them. Windows 2008, Windows 8.1, Windows 7, Windows Phone, or Windows Vista. Good job. So a few lectures ago, we saw how we identify which ports are scanned. Now in Input Management, we'll see how we identify which systems are scanned. Okay, go to Kali and open a terminal window. First, I'll prepare an Nmap query, and because I'll play with the destination IPs, it will be the last parameter of my query. Nmap is the command itself. N to close the name resolution, uppercase PN to close ping, uppercase S for SynScan. Now to keep it simple, let's scan just the top 3 ports. Now is the time to identify the destination systems. Up to now, we learned to scan a single IP. And we learned how to scan an entire C block, .0 through 24. Okay, so what are the other ways of identifying target systems? You can select a range of any part of the IP address. In the slide, the third and the fourth parts of the IP address is given as ranges. That means Nmap will scan IPs from 192.168.1.0 to 192.168.255.255. I'd like to keep the range small. I'll only define a range for the fourth part of the destination address from 100 to 150. There's only one machine between 172.16.99.100 and 172.16.99.150. You can scan more than one IP block in a single query. The example in the slide scans 2 ranges. The first range is between 192.168.1.0 and 192.168.1.255, and the second range is between 10.0.0.0 and 10.0.255.255. Since I don't have a second network on my Kali, I continue with the third example. The third example is a combination of defining a range and a single number. For example, you can scan the IPs between 100 and 140, IP 206, and the IPs between 220 and 230. So here are the results. Nmap found a machine from the range of 100 through 140, the machine with IP 206, and another machine from the range of 220 through 230. Another way to define the target systems is to give Nmap the IP addresses in a file. In a typical penetration test or ethical hacking, you will scan the network a lot of times. First, you find the hosts. It doesn't make sense to scan the entire network again and again. You'll see huge networks, so if you scan the entire network each time, the pen test will take a lot longer than you think. Let's open a second terminal screen and find the hosts of our IP block using PingScan. As we learned before, now clarify the output to have only the IP addresses of live hosts. grep command to get only the rows containing IP addresses, and cut command to get only the IP addresses from a row. Now we can redirect the output into a text file to reuse the list in following queries. But first, let me close the name resolution. Now, put a greater than character and give a file name to write the result, iplist.txt. We're not interested in the first two IP addresses, so let's edit the file and delete them. I use Nano Text Editor to edit the file. In Nano, use Ctrl-K to delete a line. Use Ctrl-X to exit Nano, press Y to save changes, and hit Enter to save on the same file. Type cat iplist.txt to look at the file again. Now we have 4 IP addresses in the file. Let's create a new Nmap query, and this time, let's give the destination systems in a file, iplist.txt. And here are the results of the 4 systems which are listed in the iplist.txt file. So let's talk about the output management in Nmap now. Up to now, we've run a lot of Nmap queries and got the results on the terminal screen. This is the default output behavior called interactive output, and it is sent to standard output, std out. In a penetration test, we should save the results of the queries to be able to analyze them later on. Hopefully, Nmap has its own output management skills. So let's have a look. There are 3 major output saving formats in Nmap. Normal output, which is similar to interactive output. That's what you see on the screen up to now, except that it displays less runtime information and warning, since it is expected to be analyzed after the scan completes rather than interactively. Greppable output, which includes most information for a target host on a single line, so you can use it to collect the information you want using the excellent grep command. We've already seen a few examples of grep command in this course. XML output is one of the most important output types, as it can be converted to HTML easily parsed by programs such as Nmap graphical user interfaces or imported into databases. There is one more magic parameter, which is O_A, to let you generate the outputs in all formats. Now, let's see the Nmap output management in action. Go to Kali and open a terminal screen. Prepare an Nmap query. For this example, I want to prepare a SYN-scan. Now we're ready for output management options. First, I want to generate the XML output using O_X parameter. O_X parameter needs the output file name. You can give the file name with the full path. If you don't specify a path, just as in this example, the file is created in the current folder. Be careful, OX, OG, and ON parameters require the full file name. So if you want the file to have an extension such as .xml, you should specify it here. Hit Enter to run the command. To see the generated file, here it is. And use the less command to see the content of the file. So it's typical XML file with tags. Here's a host tag, starts and ends. All the results about a host is listed between the start tag and the end tag. IP address, scan ports, and of course, the scan results. Here is another host tag and the scan results of the second host as well. Press Q to quit, less command. Now let's call back our Nmap query with the up-down arrow keys of the keyboard. Now I want to generate all types of outputs. Type O uppercase A and the base name of the files. Be careful, O uppercase A parameter requires the base file name of the files, not the full names of the files, and it'll put the file extensions itself. Let's look at the content of .nmap file using the less Linux command. This is almost the same as you'll see on the screen. Now let's look at the greppable output. Here there are 2 lines for each host, one to show the status of the host and another one to show the port scan results. So here's some homework to use almost everything you learned about Nmap up to now. Step 1. Find the live hosts of your network block using ping scan and save the results in all formats. Step 2. Create a host list using the greppable output of the previous scan. Step 3. Scan the top 100 ports of the host using the SynScan. Step 4. Perform version and OS detection. And Step 5. List the hosts whose 22 SSH, 3389 RDP, and 80 HTTP services are open. Let me give you a hint. Some Linux commands will help you in the second and fifth step.